Friends, today I am going to discuss about benzoin condensation reactions. It is an important organic reactions. Now, the benzoin condensation reaction is the cyanide catalyzed cyanide catalyzed condensation of condensation of two similar or different aromatic aldehyde without alpha hydrogen. Let's see the general reactions. When 2 moles of the benzaldehyde when 2 molecules of the benzaldehyde react each other in presence of potassium cyanide, ethanol and water, we get benzoin as the product. That's the benzaldehyde. We get the benzoin. Okay. In this reaction, the catalyst for this reaction is KCN or cyanide as a catalyst in ethanol water. Okay. The alternative catalyst for this reaction is thiazolium salt, like there is nitrogen, N-alkyl thiazolium salt. Okay, this is the alternative catalyst in mild base like sodium methoxide, triethylamine. Okay, so benzoin condensation is the cyanide catalyzed condensation of the two similar or different aromatic aldehyde without alpha hydrogen atoms. This is the condition for the benzoin condensation reaction. Benzoin condensation is not an condensation reaction, it is an addition reaction, but the inventor gives his name as the benzoin condensation reactions. Why I say the addition reaction? Because in condensation reaction generally, like the water molecule, CO2 molecules or small molecule like water, CO2 eliminated, but in this reaction none of the small molecule eliminated, so it is an addition reactions. Okay, that is a cyanide catalyzed addition reactions. Okay, now this is the reversible reaction. This is highly reversible reaction. Each step goes to the reverse. The product distribution is determined by the thermodynamic stability of the product and the starting material. In this reaction, the stability of the product or the product distribution is determined by the thermodynamic stability of the product and the starting material. Let's see the mechanism for this reaction. mechanism for the cyanide catalyzed benzoin reaction. This is an aromatic aldehyde in presence of KCl, ethanol, water. Okay, this is the mechanism. Cyanide ion act as a nucleophile. First attack at the carbonyl center. We get the each and every step is a reversible. So reversible array is must. We get the oxyanion. There is hydrogen. There is cyanide. Okay. In next step, there is a loss and gain of proton. That is a minus plus H plus. That is first lose these protons and then oxyanion gain the proton. So you can write in one step loss and gain of proton. So we get the OH here. This is the carbanion formation is there. Okay, and this carbanion is more stable because of the aromatic benzene rings and cyanide ions. We know that the suppose any acids, suppose take an example of the HCl. HCl gives H plus plus Cl minus. Okay, the stability of this or the acidity of the acid is depends on the stability of the conjugate base. So conjugate base of this compound for the this hydrogen, this carbon, is more stable because of the delocalizations. So this anion is delocalized over the cyanide as well as in the benzene ring. So it is a more stable carbanion. Okay. So in next step, it attack on the second molecule of the benzaldehyde. There is cyanide, second molecule of benzaldehyde. We write here like this. Attack at the carbonyl center of the second molecule of the benzaldehyde. We get the product or the step of the product. Here is OH, cyanide. Attack here is O minus pH. The hydrogen is there. Okay. Then this is the very fast proton exchange in between the OH and this oxyanion. So we write this step like this. This is the formation of the oxyanion. Let's take a proton from this. Okay, pH, and here is hydrogen, and this oxyanion pull the electrons and lose the cyanide ion, and cyanide ion is the eliminated. So we get the product OH, pH. Okay, plus cyanide ion. Okay, now why the question arises in your mind that why here cyanide minus taken as a catalyst. Okay, there are the three reasons for this. Cyanide act as a good nucleophile in first step, good nucleophile in the first step. Second reason, stabilize the carbanion. It provide more stability, stabilize the carbanion. Through conjugation third one is the better living group. In last step act as a better living group. Because of these three reasons, cyanide ion act as a catalyst in this reaction. Okay, this reaction is an example of Ampulong chemistry. Ampulong chemistry. What is meant by Ampulong chemistry? That is a reversible of polarity. Here in first step, this carbonyl center is an electron deficient center. That is a electrophilic center, nuclear electron deficient center, and this electrophilic center or electron deficient center is converted into the electron rich center, which act as a nucleophile. So there is a reversible of the polarity. So this is benzoin is an example of benzoin condensation. It's not a benzoin condensation, example of Ampulong chemistry. Ampulong chemistry. Okay, now we see the another example for the benzoin condensation reaction. Potassium cyanide, ethanol, water. Okay, in this reaction the two starting material is similar, so there is no selectivity. That is the where like this, if two aldehyde is different, then the in product on which side the OH group is present or which side the carbonyl group is present, that is the selectivity for the different group for the different starting material. But in this example, the starting material is similar, so we get the product. All mechanism are same like the first mechanism. OME. Okay, now let's see the third example. For example, aldehyde. Here is an again electron donating groups plus again aldehyde, and here is a chlorine groups. Okay, now in such examples, or we take any example, just take a general example for any different, that is suppose R, and this for the like, so is a R, this is a R dash. Now depending on the groups, that is R is equal to electron donating group, electron withdrawing groups. Okay, its effect on the reaction, when in this reaction the one aldehyde act as a donor and one act as a acceptor. So if electron donating group is present here, then it's accelerate the reaction and carbanion form in the aldehyde, and when electron withdrawing group is present, it also stabilize or it sorry when electron withdrawing group is present here, that is like nitro groups, it is more susceptible for the nucleophilic attack at this position. Okay, now see this example. OME is the meta position of the chlorine. Okay, this is a general example, or there's two example for the benzoin condensation reaction. Now let's see the example in which thiazolium salt act as a catalyst. We see the example in which thiazolium salt act as a catalyst. Let's take an example here. So using that example, we see the mechanism for this thiazolium salt, how thiazolium salt act as a catalyst in the benzoin condensation reaction. This is thiazolium salt along with the base and react with second molecule of the aldehyde. So before solving this example, first understand the which aldehyde act as a donor and which aldehyde act as a acceptor. Now this aldehyde act as a donor, means it form the carbanion on which we form the carbanion, and it acts as a electron deficient center for the attack of the carbanion. Okay, now let's see the mechanism. Mechanism for the thiazolium salt as a catalyst. Thiazolium catalyst is invented in the 2015s. Up to that, general catalyst is potassium cyanide. It is a traditional catalyst. KCN is a traditional catalyst. This thiazolium salt invented in the 2015. Now see the mechanism. Thiazolium okay, this is the methyl groups, nothing here. Okay, then in first step, sodium methoxide abstract the proton, that is the more acidic proton. The proton in between the sulfur and nitrogen is the more acidic proton. That's the mild base can accept this proton, like the sodium methoxides or triethylamine. In this example, we have the sodium ethoxide. So sodium ethoxide first abstract this proton, we get the corresponding conjugate base, or it is an ylide. It forms the ylide. Okay, and this ylide act like cyanide minus ion in the mechanism of the benzoin condensation reaction. Okay, now let's see the next step for this reaction. Benzaldehyde, then we write like this. Okay, here is anion. Now here two groups is there, nitrogen. Okay, it can stabilize by this iodine. It attack over here. We get the first step O minus, then see the step by step mechanism. First, okay, here is a hydrogen. This is also reversible mechanism. Then again exchange of the hydrogen from carbon to oxygen, that is a loss of hydrogen and again gain of hydrogen or protons, not hydrogen, this is a proton. So we get is a positive charge, sulfur, okay, this form the anion. Now this anion also stabilized by this thiazolium ion as well as the aromatic benzene rings. Now in next step is attack on the molecule of this compound. Okay, it attack on the compound. We get, okay, this is not good representation, but see here, here is again sulfur, nitrogen is here. Now after attacking this, form the oxyanion. Again the remaining mechanism is similar to the traditional mechanisms or the general mechanism of the KCN. Now in next step is oxyanion attack over here and it lose the thiazolium salt. We get the product. Okay, this is our final product. This reaction asked in the December NET exam in December 2016. Remember that in NET December 2016 this reaction is asked for the 4 mark. So understand the proper mechanism for the thiazolium salt and cyanide ion is must for the benzoin condensation reaction. So we stop here. Thank you for watching video.